Hello guys, welcome to Easy TechNest. Today we're going to discuss about an important concept. Actually, in the previous discussion in counters and shift registers, we actually wanted to discuss about K-map. Just for the example, I explained you for three K-maps, but today we'll be learning it in detail. So let us go with the first example. Here you have F equals A plus BC bar. Now we'll write the simple truth table for it. So we write down the values for A, B, C. That is for 3 bits. You will get 0, 0, 0, 0, 1, 1, 1. Or you can write like this also. So now we write the value of F. Your A is 0. B is also 0. C bar is 1. But when you multiply, it becomes 0. So 0 plus 0 is 0. Here your A is 0. And this is 0. Again, you get 0. But your B is 1 here. And C bar also becomes 1. So your output is 1. In that way, you will solve all the F column. Now, first let's try to solve this equation, whatever we have got here, the S value. Here we have got A bar, B, C bar that I have written here. Then again, I have got a 1 here. So A, B bar, C bar, A, B bar, C. Then I have A, B, C bar, then A, B, C. Here I'll try to sort out the common terms and try to solve it using De Morgan's law. And there are various properties such as associative property, distributive property, commutative property. So you have to go through all those De Morgan's laws, and that is how you can solve the Boolean expression. Here we have A bar B C bar. As of now, we do not have any common for it, but here in the second and third term, A B bar is common. So A B bar C bar plus C. Then AB is common in the fourth and fifth term. So we'll write AB C bar plus C. So what happens? A B bar plus AB, because C bar plus C, any variable with its complement in addition will give you 1. The same goes here. So you're left with AB bar plus AB. Now you can see that here you take A common, you are left with B bar plus B. So again it becomes A. Now there is one important concept in distributive law that you use to solve these type of equation. That is, you have A bar B C bar plus A. You can see that A and its complement is present. So what you will do is you will add this like A plus A bar, then you will put A plus BC bar for this variable. Whatever you have here, for the first variable add A, and another for this variable, two variables also add A. So what happens is A plus A bar becomes 1, and your A plus BC bar will become A plus BC bar. It will remain like that. So you got your F, that is A plus BC bar. Now there is another way of solving it, that is called as K-map. So how do you write a K-map? Since you have, we are solving it for 3 bits, we'll have 8 positions or 8 spaces here, or else we can call it as 8 minterms. So let us see first how to write a K-map. Since you have 3 variables, you'll separate it like this: A bar A, B bar C bar, B bar C, BC and VC bar. It is not very difficult. You just write it down from this: A bar B bar C bar, A bar B bar C. That is how you write it down. Now we should write down this minterm numbers here. M0, M1. Here the shuffling happens. M3, then M2. M4, M5, M7 and M6. Now let us see. So in the first 0th position we have 0. Then we have again 0. For 2 we have 1. Then for 3 we have 0. In a similar way for 4, 5, 6 and all 1. So you can write it down. Now for pairing we have 4 types. That is a pair, a quad, a oct, and a 16th group. As of now, just because we are dealing with 3-bit data, let us not worry about 16. We'll discuss it later. Now we have 2, 4, and 8. So now we can observe that the biggest group is quad. So I have blocked the quad. Now I have the biggest group to be a pair. Now I write it down. Now you can see that when I take this term, all the thing will get negated or it will be added up. So we are left with only a. Here what happens is we have a plus a bar, bc bar. So a plus a bar will become 1. You will be left with bc bar. So that is how you will get your final expression. Now we will see more examples. Here see, they have given a direct question and we need to solve it using the K-map. Very simple. He has given you 1, 3, 5, 7. That means the 1 value will be present at M1, M3, M5, M7. So we know how to write it. 0, 1, 3, 2, 4, 5, 7, 6. We will write down ones in all these places. So now once we have written it, we should see the highest mapping that we can do. First we'll go with 16. 16 is definitely not possible. Can we map 8? 8 is also not possible. So next best option is quad. So we can make a quad here. So B bar C plus BC. C is common. B plus B bar will become 1. A plus A bar will become 1. So you're left with F equal to C. Now we'll go to the next thing. Let me make it a single page one. That will be easy to, yeah. One thing to note here is many of you might think, let us see this example and I'll explain you why diagonal pairing is not allowed. We have 0, 1, 2, 4, 7. 0, 1, 2, 4 and 7. Here you can make a you cannot make a quad here. There is no possibility of a quad, so we go with pairs. First pair, second pair, third pair. One thing you have to understand is a K-map can be folded. So when you fold, this part will become another pair. Here many of you might arise with the question, why can't we do like this? Why is this not allowed? So as per the rule of K-map, diagonal pairing is not allowed. So now you will write it down. For this P1, A plus A bar will become 1, so we will be left with B bar C bar. Here you have for this P2, we have A bar and B bar. Then for this, it is A, B, C. And for the last one, it is A bar, C bar. Because B plus B bar will become 1. Let us see the next example. Here we have solved it using redundancy theorem. So it is very important to understand what is this redundancy theorem. Now what happens is when you are solving such questions, you might see the possibility that this pair, we have already P1 and P2. Sorry, P1 and P3. But this P2 mapping is again overlapping this. It means it is redundant. Again, it is repeating. So first we'll write down the Boolean expression using the K map. That is for the first P1 you will get yeah. First we'll solve P3. So we got AB from P3 because C plus C bar is 1. Then for the second pair we'll get A bar C because B plus B bar is 1. Now for this overlapping pair A plus A bar will become 1. So we'll be left with BC. Now to identify a redundancy theorem, the main thing you have to see that all three variables are present. A is present, B is present, C is also present. Yes, first condition is marked. Then one variable has its complement. Check whether any of the variable has its complement. Yes, A plus A bar. So A bar has a complement. A has its complement. The last condition is each variable is repeated twice. Does that happen? Yeah. A is repeated twice, B is repeated twice, C is also repeated twice. So what we do is we cut down this last whatever is in common and we just keep this. So this is our final expression. Now we'll go for the last case. Sometimes what happens is we get two types of outputs because we have multiple redundancies. So in that condition, see now we have 0, 1, 5, 6 and 7. We can we try to make a quad? No. Even if we fold the page, it is not possible. So the max you can go is pair. Now we have one pair here, one pair here, one pair here, and one pair again here. So this is multiple times it is overlapping. So what I we will do is, uh, first we'll map the main two things. This is AB and A bar B bar will remain common. For these two, we'll separate it. So what will happen is B bar C goes for one of the outputs and AC, because this A and B plus B bar becomes 1, so AC. The result is minimum but may not be same or unique. Any one of the thing can be used as a Boolean expression, not a problem. This is because of the overlapping. Here now we are going to a 4-bit input, that is A comma B comma CD. Now we have summation M, that is 0, 2, 5, 7, 8, 10, 13 and 15. We'll mark all of them. The first possibility you have to check when you have 4-bit data is, can we make 16? 16 is definitely not possible because here you have all are zeros. Only this is 1. So the first possibility you can see is you can easily make a quad here. Then you have the possibility that if you fold the page properly, you can make this corner also square. Imagine this is like playing a Rubik's cube, 4 cross 4 Rubik's cube. Every edge you can make it as a square. Now let us try to solve it. Here, A bar B, AB. So A plus A bar will become B. You will be left with only B. Here it is C bar D plus CD. D is common, so you get BD. Next we have this square. Here you have to be a bit careful. You have A bar B bar AB bar. So A bar plus A will become 1. You will be left with B bar. And for this, C bar D bar plus CD bar. C bar plus C will become 1. D bar plus D bar, you can take it as common. So your final expression will be BD plus B bar D bar. Now we have one more question. 0, 2, 3, 7, 11, 13, 14, 15. You will write down as it is. Okay, one thing I forgot to tell you is how to write this 16-bit. It is similar to the 3-bit one. What you will do is, you have 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11 and 10. Then you will go to 12, 13, 15, 14. Now let's first solve this quad, because we can easily get a quad here. What is the next other two possibilities? We cannot make a quad. The next best possibility will be having this as a pair and this again as a overlapping pair. Let us see how we'll solve it. The first chord will be solved as CD, because all this will become 1 and we'll be left with only CD. Here when we are trying to solve it, we'll definitely get A bar B bar. Since it is C bar D bar plus CD bar, we'll be left with D bar. So A bar B bar D bar. Then we have this one A B, and since C bar plus C is D, we'll get A B D for this overlapping. Now let's solve for this overlapping. So we'll get AB, then CD plus CD bar, we'll get ABC. Now, in some of the KMF solving, you might get a condition which is called as don't care condition. So we have 2, 3, 4, 5. So we'll mark 2, 3, 4, 5 as 1, 1, 1, 1. Then you have 7 and 6 as don't care. Let us see how we'll solve it. It is the same way of writing the K-map, but the only thing changes is we ignore this term. So now we have A, B bar C bar plus B bar C. So you'll be left with A B bar. Then for this you will be left with A bar B, because C plus C bar will become 1. So this is how does it look? A bar B plus A B bar. This is an XOR gate. So this is how you solve different types of K-map. I hope you have understood this video and have learned how to solve K-map. If you have any doubts, feel free to put it in the comment section. There is also one more thing that I wanted to tell. Here, if you get a capital M, you will be marking all the zeros. It will just be the opposite of it. Solving remains the same, Only the way you write the numberings, you will put a zero and you'll solve it. And in that, you will not get sum of products, you'll be getting products of sum, POS. That is how you'll be solving. If I can, I'll make a video on that also. Thank you. Subscribe to EC TechNest.